Hey everyone, Eitan from Innoviz Technologies here. I'm back again this time to talk about the Innoviz Player and some of the new useful features that we have. Now, the Innoviz Player is our 3D visualization software that allows you to view the 3D point cloud coming from the LiDAR, as well as make recordings, play them back, take measurements, and analyze the point cloud data. Now, use of these features actually requires some basic knowledge of the Innoviz Player beforehand, so if you need to get up to speed, go ahead and check out the user manual so you can be familiar with the basic operation. So today we're going to be talking about some of the new features that will help save time and make things a lot easier. First feature we're going to talk about is the multi-pixel selection tool, which allows you to create a bounding box around a group of pixels and analyze their data in a single frame. And then the detection calculator, which allows you to take a group of pixels and analyze over multiple frames their measurements. And then the third feature we'll talk about is called the zone detection feature, which allows you to create a 3D warning zone and trigger an alert every time an object enters that zone.
The first feature we'll discuss is the multi-pixel selection tool. This tool is good for viewing data from a group of pixels in a single frame. You can put a bounding box around a group of pixels and then you can export all the data from those pixels to a CSV file. So to open this feature, we go to the Tools menu, Multi-Pixel Selection, and you'll see a bounding box appears with a menu on the right. Now if we select, let's say we go to a frame, we have a person that we'd like to choose. Let's choose this person right here crossing the street. If we select a pixel on that person and click Reset Selection Box, a box will automatically appear around that pixel and the size will be 2 by 2 by 2 meters. And now let's say the object isn't exactly 2 by 2 by 2 and we'd like to adjust it. So we can adjust the position and size and rotation from these values over here in the selection box transform window. So if I want to make it maybe 1.8 meters tall, maybe 1 meter wide, I can just adjust the numbers here and you'll see the box changes. And we can actually save the values of the selection box this way. If it gets moved or removed and we want to put the box back to where it was before, then we can just load it. But an easier way of transforming the box is actually to click on it, and then you'll see we have several hotkeys, W, E, and R, that lets us adjust, resize, rotate, move the box however we'd like. So if we start with W, you'll see that we have 3 axes, 3 arrows. Each one, if we drag it in either direction, you'll see that the box moves along that axis. Up and down, side to side, forward, back. And if you click on one of the faces of the cube inside, you can actually move the box along 2 axes. Now the second hotkey is E. Once you've clicked on the box, you hit E. Then you can rotate the box just by dragging on one of the rings around the box, depending on whatever axis you'd like to rotate. And the last button, R, is for resizing the box. So there's 3 different dimensions that you can resize it. And if you'd like to do it in all 3 dimensions at once, you can click on the gray box in the middle and drag the mouse to make it bigger or smaller. Okay, so let's say we have the box how we'd like it right now around this pedestrian right over here. And we can see that we have 649 pixels inside the box. And over here we have all the measurements of those pixels. Now, this is just a preview window, so we don't have all 649 pixels. We have maybe a few dozen or so, and the rest we can export to a CSV. But the preview window does show what types of measurements we do have for the pixels, which includes timestamp, pixel number, column, row, Cartesian coordinates, polar coordinates, distance measurements, and reflectivity and confidence measurements as well.
The second feature I'll show you is called the detection calculator. This feature, similar to the multi-pixel selection tool, puts a box around a group of pixels
around an object that we're interested in, and it can measure over multiple frames all the measurements of those pixels. So because it's using multiple frames, we'd like to use this on a static target and not something moving, because that'll have different distance values. So for this example, we can use this sign right here. I will open up the tool the same way, and we'll see that it automatically puts a bounding box around the pixel right over here. And using the same tools as before, we can reposition the box and resize it. So let's say now we have the box that we are interested in. We can make it a little bit shorter. And now before we calculate, we have a few other parameters we can adjust. One of them is called the ground truth distance. So if you know the actual ground truth distance of the target, you can enter it here, and that'll be used to calculate the distance bias. If you do not know the ground truth, then it's okay, you can just leave it at 0. For this, I will just enter 32 meters just for the demonstration. And then the next line, you enter the start and end frame over which you'd like to run the calculations. So by default it has the frame 20 and then the previous 10 frames. So we could just leave it at that. And then the last parameter is the false alarm target, which right now is set to 5%. We can adjust it however we'd like. And this is to filter out any of the low confidence pixels that we are not interested in. And once those are all set, we can actually click calculate. It'll run over those 10 frames. It'll calculate the statistics and show them below. So here we have over 10 frames, 236 unique pixels inside the box. And the true positive rate was 98.01%, meaning how many of those pixels we saw over the 10 frames compared to the theoretical number that we could have seen over 10 frames. And then we have distance statistics, including average, median, distance bias according to the ground truth we entered, standard deviation, and then the same statistics for reflectivity and confidence, average, median, and standard deviation. Now, all those statistics we can actually export to CSV, including all the raw data and individual measurements that will be included. We export them to CSV, save it wherever we'd like, and then we can use that data to analyze in Excel or MATLAB or any other application that is relevant. So the last feature I'm going to show is called the zone detection feature. This feature allows you to use the LiDAR as a monitoring sensor for a certain area with a defined zone and trigger an alert every time something enters that zone. So we open up the feature the same way from the Tools menu. Just like the other features, there will be a bounding box and a menu on the right. Now for this example, I'm using the same sample recording, and I'd like to put a zone just above the crosswalk to detect if there's any jaywalkers. So I'll take the bounding box, I will move it, to the crosswalk, move it just above. Just go back to the first frame. Make it the relevant size and rotation and everything. And this feature also lets you show only the pixels inside the box. So we see now that there's no pixels inside the box. And another thing about this feature is that you can actually put more than one box or more than one zone to trigger an alert. In this case, for demonstration, we'll just use the one box. We can actually add a label to it and call it jaywalking zone. And you'll see that the label is here on the box. We can change the size if we'd like. And you can also save the box's values and duplicate it and put it in another area as well. So once we have it in this correct position and size, we can actually enable or disable the alarm and the alert functions. Now the alarm is a trigger that'll happen when something enters the box, and it'll show a warning at the top of the screen and also trigger a sound. The alert is if you want to send a remote message somewhere, you can send an HTTP message, and here you have alert options, and you can put whatever you'd like in that message. And then lastly, we also have a keep alive option. So not just for an alert whether something enters the box or not, but you can also send periodically a message showing that the player is alive and working. And that's called the keep alive option, which is down here. For now, we'll just use the alarm so you can see it on the screen. So the alarm that we'd like to show, let's say it'll be jaywalker detected. You can adjust the text size here. And over here you can set the minimum number of pixels or the minimum number of frames before triggering the alarm. So the minimum number of pixels will be how many pixels need to enter the box before the alarm is triggered, to make sure that it's an actual object of a certain size. And a certain number of frames is if one frame is not enough and you want to make sure that the object is inside the box for 10 or 100 frames or whatever, then you can also set that value over here. So for now we'll just leave it at the default values. And now if I hit play, as soon as people start crossing the street, somebody should enter the box and there will be an alarm triggered. And it'll stay triggered. The message will stay up until the parameters are not met anymore. In this case, less than 100 pixels will be in the box, and then the alarm will stop. And there you have it. That's the zone detection feature. It's very useful, and we actually have some YouTube videos showing a lot of creative uses of this feature.
So I hope you enjoyed these videos and you're able to make use of these features, including the multi-pixel selection tool, detection calculator, and the zone detection feature. If you have any questions, feel free to contact us and email us, and we'll be happy to answer. I'll see you next time.